This is a 3D segmented Arabidopsis ovule sample, and we will use it for the custom coordinate system. There are some processes here, the Cell Atlas 3D, that are good for detecting the different cell layers of the sample, and we can skip the process and open figure 4b, which is the sample that already has the base removed, and also there's only the L1 layer, so the superficial layer of the ovule here. And so the principal directions of growth and other cell axis quantifications, such as shape analysis or microtubule directions, are calculated for each cell individually and can point in different directions for different cells. So it can be useful to align them into a specific direction, for example, to measure the cell growth along the proximal distal axis of an organ, which is this one. And a custom axis alignment can be computed by selecting first the cells for creating custom direction. Here they were already selected, but you can click here and select few bits of the cells you're interested in, and go to mesh selection, extend to whole cells to select the entire cells, as you can see here. After you have the cell selected, you can go to miscellaneous Bezier and create a Bezier from cell file. So it will create a Bezier line from these cells. So the Bezier is one of the methods for creating the custom coordinate directions, and can be preferred when the tissue has a simple topology or when the organ axis follows a fixed direction, so a central line through the organ like this one. While for tissues with a high curvature, the creation of custom directions using a cell distance heat map can be an easier solution. So now that I run this process, I can collapse the Bezier points to form a line. So here and then from that I can use heat map, measures 3D, location, cell distance, so I can measure the distance in the cells from these selected cells. And usually we select warm helix as a color map, so that you see that, so you can see that the cells that are closer to this line are darker and the ones that are further away are yellow. And now we can run mesh cell axis 3D, custom, create Bezier grid directions. Okay, and now we have the axis here of each cell. And now we can run create surface direction, and this will generate directions towards the surface for each cell. And then we can create an orthogonal direction of the Bezier. And then after that we can run compute shape analysis and then display shape axis 3D. Now that we run display shape axis 3D, we can select custom X, and this will tell us, and this X will correspond to the cell length, while Y will correspond to the surface direction to the depth, and X will correspond to the orthogonal direction to the width. What we can also do, we can also remove the cell axis, remove part of the cells with extend to whole cells, maybe a bit less, Okay. Can remove the central cells. Okay. Now we can select one cell on the top here and extend to whole cells. And we can create a cell distance that will generate distal proximal coordinate. And after setting the custom coordinate systems, then you can compare them to different parameters such as volume, growth, and I can show you what you can get. This is the mesh I showed you with the distance from central cell file. Then you can set specific coordinates like this one, and you can calculate the shape PCA with the cell volume, length or depth. And then you can extract these attributes and generate graphs with a Bezier coordinate over the volume, length, depth, width or anisotropy. We can also try with the Arabidopsis leaf. So we can go to File, Open, and now with this one we can select few of the cells at the bottom and go to Mesh, Selection, Extend to Whole Cells. You need to select Heat Map Measures, Cell Distance, and we can change the color map to worm helix. Okay, now you can see that the cells are colored by the distance from the base. With that you can now go to Cell Axis, Custom, and create heat map directions. Now you can go to PDG and display growth directions and select a custom option for heat map, and you can select something like custom X growth proportion, and this will display the growth proportion according to the X value that we assigned here. Otherwise we can also do it for the Y axis. So the cells that elongated more during this growth have grown more in the Y axis relative to these base cells are shown in yellow.